Hi guys, Ms. Zimmer here with our next lesson, 12.4, Finding Segments. So these look a lot like 12.4, Solving for Angles, and they do. So you really have to read the instructions carefully and look and see what's labeled. There are no degree measures here, so it's not labeling angles, it's labeling segments. Yeah, we have three different types of problems here. We have two chords that intersect in the first example. On the first chord, we have segment A and segment B, and if you multiply those together, they will equal segment, I wrote it incorrectly, D times C on the second segment. So A times B on the first segment, D times C. You can't mix and match on that. So let me give you an example of that. I am going to use the numbers 8, 6 for these two, and 20 and X for the other two. Now, these are not to scale, so watch out if you're saying, this doesn't look right. Don't worry, it's because I did not draw this to scale. So 20 and 6 are on the same segment. Those were my A and my B. So 20 times 6 equals 8 times X. 20 times 6 is 120, and 8 goes into that 15 times. So now X is 15. And again, as I said, it's not to scale. It should be much longer if it was actually to scale in that picture. But X is 15. Now, the next problem. The next problem has two secants, and I sort of squiggled the exterior part because we call that an exterior secant segment. It's just the part of the secant that's outside, and we know exterior means outside. So sounds kind of ominous, but it's just a long exterior secant segment, but it just means the outside part of the secant. So W, the outside part of the secant, is outside the parentheses, and then the whole secant is inside the parentheses, W plus X. Y, the other exterior segment, is on the outside of this set of parentheses, and then inside the parentheses is the whole secant, Y plus Z. Now, having that set up, let's go ahead and solve a problem that is like that. Let me change these to some numbers, and we can do a little bit of solving. We have 6 and 8, 7 and Y. So 6 and 7 are our exterior secant segments. So they go on the outsides of the parentheses plus on the inside. And then 6 plus 8, which yes is 14. And 7 plus Y. So we can go ahead and make that 14. And 14 times 60, 60 and 24 more is 84 for this side. Equal to 7 times 7 is 49 plus 7Y. Subtract 49, 35. Over here, 7Y, and then divide, and Y is 5. Sorry, that's starting to fall off the board a little bit. So Y is 5. All right, so they can be a little tricky, but if you just follow the pattern, these are the external secant segments, and then the whole secant and the whole secant on the inside. It'll fall right into place. Just follow that pattern. Make sure you have it written down. Now, the next one looks somewhat similar, but it's got a tangent, and they use T to represent the tangent. So what do we do with the tangent? Just square it. What do we do on the other side? Well, just like we did with the sides here, the external part on the outside of the parentheses times the whole secant, Y plus Z. So let's do an example with that one. we have z. Or let's go ahead and call that x so we don't get it mixed up with our letters here. We're going to solve for x. And this is going to be 8. And this is going to be 16. So in this case, we have our tangent is x. So x squared is equal to 8 times 8 plus 16. So 8 plus 16 is 24. And we can do a quick calculation. I did not bring my calculator in here, but luckily I have my phone handy. And a quick calculation there. 8 times 24 is 192. And the instructions on this one would say, find the answer to the nearest tens place. So we would just find our square root and 13.9. So frequently these would have to be rounded because it may not be an exact answer, and that's okay. All right, let's do a couple more. So again, reiterating, these are the 3 types of problems. Identify, is it 2 chords crossing, 2 secants, or a tangent and a secant, so you know which pattern to follow. All right, here's another example problem. This one has two secants, 20, 14, 16, and here is x. So in this case, this is where we need our secant, external secant segment. We have 14 times 14 plus 20. We have 16 times 16 plus x. So 20 plus 14 is 34. And 14 times 34 will give us 476. And we have 16 times 16, which is 256 equals plus 16x. We can subtract 476 minus 256, and we get 220. And we have 16x, and we just divide 220 divided by 16, and it comes out to 13.75. We certainly don't want to round unless they ask us specifically to round. That's 13.75. My point kind of got stray over there. All right. Another problem with our 2 chords. We've got M here, 3 here, 7, and 6.5. So 3 and 7 are on the same chord. Multiply them together. Yes, that is 21, as we know. So I'll go ahead and write that down. And then 6.5 times M on the other side. So all we have to do to solve that one is divide 21 by 6.5. And we're in good shape. M is equal to 3.2, and that is an approximate. It's perfectly fine. If they gave you decimal numbers, they would tell you to approximate. All right. Let me take a look and see if there are any others that we need to look at. I think we're in pretty good shape. I'm going to throw one more problem out to you. One more problem that we have. Could have a little bit of algebra in there. So we're going to give it a try. And again, we have our external secant segment here and here. So x and 3. Now, on the inside, the secant itself is already added together, so we don't have to add that. And here, 3 plus 4, we do have to add that one. Okay. So, So now we just have 6x equals 3 times 7, 21. And we can just solve that. 21 divided by 6. And we're done with 3.5. So I hope this is helpful to you. I'll see you again the next time.